Good morning, good afternoon, and good evening, everyone watching this video. You're most welcome to our channel, Electricals Explained, whereby we talk about several electrical equipment on the construction and the principle of operation. So in our comment section, you can always inform us on which electrical equipment you would wish us to explain. So for today, we are looking at a brushless generator. So, and basically we are talking about the construction of a brushless generator, and in the next video we shall be talking about the principle of operation. So, and the construction of a brushless generator, basically like any other generator, we have a shaft. This shaft is coupled onto the prime mover. So at this end we have a prime mover, and this is our coupling onto the generator shaft. Basing on different designs, they put several equipment, several components of the generator on different positions, but we shall see that at the end. So for purposes of explaining and bringing out the point, we may not specifically go by any design. So to start with the main rotor, usually we have our main rotor. Say for example it is positioned at this point. Then also we have the stators. So the stator, what we may call the armature, is where the voltage is induced, and then we have our current. So call this the main generator's rotor, stator, and then call this the rotor. Basically we have the field and we have the armature. The field is the rotor, where the field is created, and the armature is the stator. So basically we feed the stator with a DC, with the rotor with a DC, positive, minus. So meaning we have to also have a generator that will generate for us that DC. Like any other generator, it has the stator and it has the rotor. But within a brushless, it means at any point we shall not have brushes. So that means that for example here we shall have an output from the armature, but with this other generator the armature is the rotor. Say it outputs a 3-phase. So this 3-phase, basically I'm exaggerating a figure, but this rotor, this rectifier diode that I'm demonstrating here sits exactly on the rotor, on the shaft. So we have a 3-phase which is fed into this rotating diode, and then we are able to get a DC that we supply to the main rotor. So from where does this rotor get its field? Basically, what I hadn't mentioned before, for generation to happen, we basically need 3 elements, and those 3 elements are: we need motion, 1. Number 2, we need a conductor, where a voltage will be induced and then a current. And number 3, we shall need the field, the magnetic field. So when you have these 3, you're able to generate. So going back to our generator here, this is the main generator, what someone else may call the alternator. And then we also have the exciter. So basically it means that on our exciter, the stator will be the source of the field. So meaning that we also have to supply our stator with the DC. So where possibly can we get the DC? We shall need an AVR. Say for example we have an AVR at this point. So this AVR will be responsible for supplying a DC. At this point, then the DC creates a field. It cuts the conductors of the rotor, which is on the shaft, on the rotating shaft, and then we get our 3-phase. At this point, then the 3-phase is rectified by the rotating diode. So now the question is, where does the AVR get its power supply? So we have 2 types of brushless generators. One is a self-excited, and the second is one with a PMG, what we call a permanent magnet generator. So both of these methods can be used to supply power to the AVR. So I start with the self-excited. Is what I will explain for you. So with the self-excited, literally it means that, let me change colors here so that we don't lose track. So within this main rotor, it will be capable of having residual magnetism. So with this residual magnetism, once the rotor starts to rotate by the prime mover, it could be diesel engine, it could be a gas turbine, whatever the prime mover, this residual magnetism, remember, it has a north, it has a south. So we are making this field to rotate like we saw the 3 components required. The field is the residual magnet, is created by the residual magnetism, and then the motion is by the prime mover on the shaft, and then the conductors are within this stator. And so in that way we are able to produce a voltage. So from this point, after producing a voltage from the 3-phase conductors, we then supply to the AVR. So basically what the AVR does with this 3-phase supply, it monitors the voltage, and this voltage as well becomes its supply power. But there are limitations onto this kind of setup. One of the limitations is that in cases whereby we've taken a long time without running this generator, we shall have the rotor losing the residual energy. So in this case, it means that we basically have no field to start this generator. That is one of the limitations. So basically, and actually temperature is one of the causes of the loss of residual energy. And the second is that once we load this generator, usually there are fluctuations in voltage. So the fluctuation in voltage it so happens that the same voltage is supplying our AVR. So before the AVR can do the supply to the exciter, if we have a drop in its own supply voltage, then we shall have a problem with controlling the output voltage. So those are two of the limitations that we have with having a self-excited. So the other alternative is having a permanent magnet. So for the permanent magnet, let me go back to our color black. So basically we shall have a permanent magnet at this point. So a permanent magnet, basically it means that we are not losing its magnetism. And then we have its stator. So this permanent magnet, basically it has the north-south, so it creates a field, and because of the rotating shaft we have a rotating magnetic field, and then a voltage is induced within this stator, and then a current will flow. So basically this current is AC and is usually a single phase. So we have a single phase being supplied to our AVR. It rectifies the voltage supplied to it to supply a DC to the exciter's stator. Basically that. So this is how everything is assembled onto this shaft. Then these red lines, they are always also connected because the AVR, as the name is, automatic voltage regulator, it will have to regulate what it's able to monitor. So it will monitor this three-phase output. It will have to monitor it through this connection that is provided to this AVR. So basically that is the assembly of the components of the brushless generator. So in case you have any question or something that hasn't been elaborated on very well, you can hint on us through the comment section and we are able to give you a response. And you can subscribe, you can like, you can share if you think this content is helpful. Before I conclude, I would also wish to comment, like I had promised, the assembly of this equipment on the shaft is dependent on the designer. So for example, this is a permanent magnet, and basically with a permanent magnet, it has a permanent magnet generator has a permanent magnet, and then its stator, just two components. But with the exciter, first of all, it has windings within the rotor, it has a stator, and then a three-phase output rectifier. So this is a little bit more complicated. So it is usually in most cases it will be assembled to the part that is so close for someone to carry on maintenance, because it's the part that may probably face breakdowns and we may need quick access to it. So it is usually can be mounted on this extreme end. Yeah, with with the rectifier diodes as well, because the rectifier diodes are also a crucial element within this generator. Yeah, so basically give us your comments, your feedback about this video. Thank you all, thanks for watching. See you in the next videos.